All right, we are now continuing on with Chapter 7, Lesson 4, and we are now on page 535 of your textbook. Example 2. This example, just like the one before, is pretty much handled the exact same way as everything else we've done, only now we have a negative coefficient. But you're going to see that really nothing changes at all. So I'll begin by blanking out most of the screen, and let's get right into this problem. So first step, rewrite your equation all over again. Please write big enough so you have enough space to actually do work. Now, I would be doing this on a separate sheet of paper if I were you, and this will count as your notes, as documentation. My first column has my equation over here, as you see. My second column over here will have a t-chart. That t-chart is going to explain what's happening to my variable. The variable in this equation is the letter y. So this t-chart is telling me about the letter y. In my t-chart, or actually in my equation, excuse me, I see that y is being first multiplied by -2. Some students get confused as to when it's subtraction or when it's negative. If you see this sign and there's nothing in front of it, no number or operation or anything else, then you can assume this is a -2. If there's something in front of it, it's probably a subtraction sign. So that's how you can tell the two apart. So we have multiplication by -2. I wrote that right here in the first space. Then after this happens, we have -7. So we have subtraction of 7. These are the two operations happening inside the equation. In the spaces below, I'm going to write down the opposites or inverse operations. The opposite of multiplication is division. The opposite of subtraction is addition. And then the same numbers that were with them come right on down. So there's no change there. These two steps on the bottom that I'm circling are the two steps we're going to use to solve our equation. The only question you have to ask yourself now is which one comes first. But if you remember, on the top of page 534, it told you to undo any addition and subtraction first. And here I have some addition. So I can undo this subtraction of 7 by doing the opposite. I will add 7 right underneath it. The equal sign acts like a balance. It's the middle. It keeps the left side balanced to the right side. If I add 7 over here to the left, I must also add 7 over here to the right. Notice I did not touch this -2 times y yet, so it'll just go ahead and fall on down as I continue to solve my problem. Here I was subtracting 7, and then I added 7, which gives me a balance of nothing. It turns to 0, so I'll just leave the space empty. Then I have my equal sign, which drops on down, and now I have some easy math, 3 plus 7. 7 plus 3, or 3 plus 7, is equal to +10. So I've undone all the addition and subtraction. Now I need to do the division and multiplication. In this case, I'm going to go ahead and divide by -2. I show division with a fraction bar. I'm going to divide the left-hand side of my equation and the right-hand side of my equation by the same number, -2. -2 goes into -2 one time. So I'm left with a single y. My equal sign, like always, just continues to drop down, and now I'm left with this fraction, 10 divided by -2. Now, a positive divided by a negative, I know is a negative, so now I just work with the numbers. 10 divided by 2, that's 5. So I suspect that my answer should be y equals -5. But before I can move on, I must check my work, because there's no point in going on if I'm making mistakes. So let's go ahead and check. You begin by writing your original equation all over again. -2y minus 7 equals 3. Then I will go ahead and wherever I see a y, I'll plug in a -5. So it's -2 times -5 minus 7 equals 3. We need to check to make sure that this side does in fact equal 3. I'm going to use the order of operations, or PEMDAS, and I know that -2 times -5 will happen first. A negative times a negative is a positive, so I don't need to write a sign. 2 times 5 is 10. Now I have 10 minus 7, we hope, equals 3. I'll go ahead and use subtraction, 10 minus 7, and that does indeed equal 3, which is what it's supposed to equal. So since this is true, I know this is in fact my solution. Now, if you have any questions about this problem, anything that sticks out, a step in the process that you're not sure how I got there, please write it down somewhere on the side so I can address that in class tomorrow. If not, let's go ahead and just move on to the next example. I'll clear my screen out. And we do see here on the screen that indeed we did have negative 5. So let's go ahead and go on to example 3. Get your paper out, get a new nice space, and let's begin the process all over again. You're going to learn very fast, if you haven't already, that algebra is basically a bunch of repetition, just like a lot of math processes are. But once you get to learn them a couple of times, you pretty much learn them for life. So let's go ahead and try this next example. This next example is a bit different because now you have a fraction. And most of the time, students and people freak out when they have fractions. But as you guys have seen in my class, if you just take your time and work it out and thoughtfully, a lot of times these fractions will end up being pretty easy to deal with. So first step, let's go ahead and write our equation all over again. I have 4 plus 1/5, the fraction, times r equals negative 1. That'll be my first column. And just like my other examples, I'm going to make a t-chart that explains what's happening to my variable r in this case. Well, let's look at letter r. The first thing we see happening to it is that's getting multiplied by the fraction 1/5. So we have multiplication times the fraction 1/5. Then it gets added by 4. So we go ahead and just add 4. These are the two operations happening inside the equation. Now beneath, I'm going to write down the inverse or opposite operations. The opposite of multiplication, we know, is division. And the opposite of addition is subtraction. The same numbers come with them. Now, here is where it gets a little different. There's one thing that's different here, and that is this part, dividing by 1/5. We learned in chapter 1 that when dividing by a fraction, you actually do the inverse. You're going to multiply by the reciprocal. Reciprocal means when you flip the fraction upside down. That's the easy way of remembering it. So 1/5 turns into 5/1. So basically, we're going to multiply times the reciprocal of our original fraction. Now, if you don't remember what reciprocal means, make sure you make a little note of it on the side, and that you know that when you use it, basically all you do is turn a fraction upside down. Make your notes as you need. So here's our two steps, multiplying times 5/1 and subtracting 4. These are the two steps. This is the only example and the only time where you're going to have something different like this is when you're dividing by a fraction. So it's very important that you make a note of this because on your homework you will have some problems that deal with dividing by fractions. So you're going to need to come back to this example to review. Now let's go ahead and follow our rules that we had established for us on page 534. They said to get rid of all addition and subtraction first. So in that case, I'm going to go ahead and do my subtracting of 4. I subtracted from the 4 in the front of my equation, and I also subtract from whatever's on the other side of my equal sign. In this case, the negative 1. 4 take away 4 is 0. So this 1/5 times r just falls down. My equal sign falls down. And now I have some math to do, integer math. Negative 1 take away 4 more. If I'm at negative 1, subtraction means I'm going to go left on my number line 4 more spots, which is a negative 5. Or I can also just use the additive inverse. I have negative 1 minus 4. The additive inverse tells me keep your first number the same, subtraction turns to addition, and change the sign of the second number. I could see easily now that 1 negative plus 4 more negatives is 5 negatives. So that's just a different way to get the same answer. So now I've cleared away all my addition and subtraction. I must now do my second step, which is get rid of multiplication and division. And I'm going to, according to my chart here, multiply times 5/1. But you know what? I realize that multiplying times 5/1 is exactly the same thing as just saying times 5, isn't it? Because 5/1 and the whole number 5 are exactly the same thing. So I'm just going to go ahead and write times 5 over here and times 5 over here. It's the same exact thing. I may not continue my work, and I will go on. And I know that when I'm multiplying a number and then dividing by the same number, which is what's happening here, I'm left with just my r. Multiplying a whole number times its reciprocal gives you a 1, so I'm left with just 1r. Make a little note to yourself if you need to. When you multiply a number by its reciprocal, you get 1. You may want to use a little better handwriting than I did. Of course, you can always rewind this and take your time writing it nicely. I'll continue with my equation. A negative times a positive, I know is a negative, and 5 times 5 is 25. So I suspect that R equals negative 25. But you guessed it, I'm not done yet. I still must check my work. So let's go ahead and check it. You start off with the original equation, 4 plus 1/5 R equals negative 1. Wherever I see an R, I'm going to plug in a negative 25. Okay, I'm going to refer back to PEMDAS, or the order of operations, and I know multiplication comes first. Here I have a fraction times a whole number. So we learned in chapter 1 that when we multiply fractions, that we go ahead and make sure we have two fractions to deal with. So I'm going to change this negative 25 into a fraction by putting it over 1. The rules for multiplication of fractions say you multiply the numerators. So 1 times negative 25 is a negative 25. And then you multiply the denominators. 5 times 1 is 5. If you remember, like we said before, all fraction problems are basically divisions. So negative 25 divided by 5. A negative divided by a positive is a negative. 25 divided by 5 is 5. So this whole thing right here turned into a negative 5. Now I have the plus 4. That just comes right on down. And then the rest of my equation, which comes on down. And now I have to do the rest of my math work. If I have $4, but then I get a bill that says I owe $5, I know I still owe $1. Or if I want to use a number line, if I'm at positive 4, plus means I'm going to go to the right, but then the minus sign means switch directions, so I'm going to go to the left 5 spots, and I end up also at negative 1. Since this is a true statement, this answer is also true. I suspect that we're going to need a lot of practice with these fractions, so please, if you have any questions about any of the steps here, be very specific when you ask them in class, so that way I can address it properly. I'm finally going to go ahead and go on to example 4. And example 4 is a word problem. Now this example is interesting because it's not just about solving. They actually want us to create a problem based on an equation, something we haven't had too much practice with. So we got to start somewhere, so we might as well just go ahead and start here. Now, I already read this expression, and I'm hoping you guys might have read this, this example, and seen that it has to do with this kid or person named Bruno goes to the arcade, plays some games, buys some drinks, and they model it with the expression that we see here on the screen. What I want to do is kind of use what we've been doing so far to make our own, or to explain how this whole equation works. So let's go ahead, and I'm going to black out, or white out in this case, this example, fill it in. And now, first step, like always, let's write the equation they are asking us to solve. I know they want the word problem written first, but I think it'll be easier to solve first, and you'll see why as I go on with this. So let's write our t-chart. What do we see happening to the letter x? It's being multiplied times 2, and then we are adding 17. The inverse of multiplying is dividing, and the inverse of adding is subtracting. We know these are the two steps we're going to follow. According to the rules set forth on the previous page, we get rid of addition and subtraction first, so I will go ahead and subtract 17 from the left side of my equal sign and from the right-hand side of my equal sign. This 2x goes ahead and drops on down. 17 take away 17 is 0 or nothing. 23 take away 17 is 6. Now I get rid of all multiplication or division, and I will go ahead and divide both sides according to this by 2. Fraction bar we use for division, and I'm dividing by 2. 2x divided by 2 is 1x. 6 divided by 2 is 3. So I'm going to go ahead and stop there. I'm very sure that this is the correct answer, and I can check really quick. 3 times 2 is 6, plus 17 is 23. Now I'm saving this third space to help us write a problem. I want to talk about the two steps we have here. We have dividing by 2 and subtracting 17. So if you're ever asked to make a word problem from a math equation, I would say your best bet is almost always to stick with money. So let's go ahead and take this equation. We know that we have a total of 23. So I would make a story where we have a total of $23. You can say it in a couple different ways, but basically you have a total of $23. And then using these two steps, let's explain what we're going to do. Well, subtracting 17 means you spend $17. So you make up some story that causes you to spend $17. You bought, I don't know, you played video games, as this example uses. Maybe you bought comic books. Maybe you went to the store and bought, I don't know, some accessories for your iPhone or iPod or whatever you have. Whatever it is, it's up to you. You spend $17. Now, if you have 23 and you spend 17, you know you're left with $6. Okay, well, you have one more thing to have to show, and that's dividing by 2. Dividing by 2 means you have two things. You put something into two separate groups, or two equal groups. Dividing by 2 means putting something into two equal groups. So basically, you're going to buy 2 of something, in this case, that costs exactly the same. So they used soda. Maybe you bought soda. Maybe you bought candy. Maybe you bought some really cheap socks. I have no idea. But all you have to say is that you bought 2 things. And there you go. You have the basics for your equation now. And using this, I'm going to go ahead and take this off the screen. You should have it on your notes, and you can look back at what the book wrote. And the book uses this information, and they said Bruno spent $23 at the arcade. So that's our total that he had. He purchased 2 drinks, so there's our dividing by 2, and he spent 17 on games. There's our subtraction of 17, all in a word problem. Now your goal, or your objective now, is to go ahead and solve, let's see, A, B, C, and D. Refer to the previous examples 1, 2, 3, and 4 to solve these problems. If you have any questions, come in the morning before class so we can maybe check your answers or just try to get some resolution. Thank you, and good luck, guys.